All right, this is section 3.3, graphing systems of linear inequalities from Algebra 2. So our objective is to understand how to solve a system of inequalities using graphing. Well, the first thing we should think about, since we've just been doing systems of equations, is, what's the difference between an equation and an inequality? Remember, an equation has one exact solution. Inequalities have infinitely many solutions. So, what do you guys think it would look like, the system of inequalities would look like? Well, here, let's graph them and show you. So remember, going back to graphing inequalities, you have to treat it like a line, but then worry about shading and all that stuff. So first thing I'm going to do is I'm going to focus on one line. And I'm going to start with this inequality first. Now remember, because it's y is less than 2x plus 1, it's going to be a dashed line because it's less than, not less than or equal to. So I'm going to graph that here for you. So there's the graph of the actual line there. Remember, it's dashed because it's less than, not less than or equal to. Now we have to put in a test point to see where it works. And again, the test point that I always like to use is 0, 0 if I can, if it's not on the line. So I'm going to plug in 0. Is 0 less than 2 times 0 plus 1? Well, is 0 less than 0 plus 1? 0 is less than 1. So instead of shading all the way, though, I'm just going to draw an arrow in a couple places showing that I'm going to be shading towards 0, 0. And you'll see why I'm doing that in a second. All right, now I'm going to graph this second inequality. Y is less than or equal to negative x minus 3. Now that less than or equal to, remember, it's going to be a solid line. So there's the line of y is less than or equal to negative x minus 3. Now we have to figure out which way it's going to shade. And again, I'm going to plug in 0, 0. Is 0 less than or equal to negative 0 minus 3? Well, is 0 less than or equal to negative 3? The answer is no. It's not less than negative 3. Negative 3 is less than that. So we're going to have to go away from the 0, 0 point. Now, the actual shading of our inequality, or our system of inequalities here. Well, first let's talk about it. If this was just a linear system, so just a system of system of equations, this would be our solution. We'd only have one solution. But this is a system of inequalities, so that means there's infinitely many. And what we have to do is look at the region that is shaded, that both ways would shade to. If you look here, or in this piece here, only the red is shaded that way. If you look in this quadrant right here, nothing shaded that way. If you look at this one in this area, only the blue shaded that way. So we need to find the one that has both of them facing that way. And if we look in this area, this is the area that has both arrows pointed towards it. So that means everything going on infinitely long in that part of where they intersect, or that area that's overlapped by where they intersect, that is where our solutions lie. And we have infinitely many solutions, remember. All right, so let's try another one here. I'm going to graph this first one in blue. And again, I'm going to put in a test point with 0, 0. So is 0 less than negative 3/4 times 0 plus 1? Well, is 0 less than or equal to positive 1? Well, yes, it is. So I'm going to draw my arrows going this way, because this is the way I would shade on my line. All right, now I'm going to draw my 3x plus 4y is greater than 16. I'm going to do that in red. Now, there's a line for that, and I converted it to y slope-intercept form there to make it easier to graph without any fractions as the intercepts. But now we got to look and see the shading. So I'm going to plug 0, 0 in again. I'm going to plug it into the original one. So 3 times 0 plus 4 times 0. Is 0, 0 greater than 16? Well, no, it's not. So we're going to shade up from there. Now, if you look at these two lines, you can notice these are parallel lines. So what we have to look at is, do we have any lines that overlap? Well, this is the area that the blue section would shade into. And then this is the area that the red line would shade into. Do I have any overlapping? No, I don't have any overlapping, so this problem is actually no solution. There is no solution that works for this. So this is a no solution problem. There is not one point that works for both of these inequalities. All right, let's try this one. And I'm going to let you guys try this one on your own. There's some graph paper on Schoology if you guys want to print that out and use it. Try it on your own. I'll show it up on the board so you guys can see what I got. All right, here's what I got for my solution. Check your guys's, see if it's the same. Let me know if you have any questions. Here's another one I want you guys to try on your own first. So try it on your own, get out some graph paper and draw it on there, and I'll show you the answer here in a second. All right, with this one, you guys can see that the two lines are parallel. The two inequalities are parallel lines. But the difference between this one and the one I showed you before is that they both shade towards each other. That means that all of the solutions are going to be in between those two lines. All right, here's the last one. And let's talk about this one because it looks scarier than it really is. So it's going to scare you guys because there's three inequalities, but it really shouldn't scare you guys. All you have to do is graph each of the inequalities and then see which area is shaded between all three. So I'm going to start out with the x is greater than 2. Remember, we always look at this like it's x is equal to 2, so it's going to be a vertical line. So let me get that for you. So you can see it's just going to be a vertical line at x equals 2, and since it is x is greater than or equal to 2, we know it's going to be solid, and greater than 2, we know we're going to go over to the right. So I'm going to draw my arrows in there because I know that's the way I would shade for that inequality. All right, now I'm going to graph this inequality, and before I graph it, I'm going to convert it to slope-intercept form because I think it's just going to be easier that way. So I'm going to make this y is less than positive 3x minus 1. Now I'm going to graph that with a dashed line because it's less than, not less than or equal to. Now we have to put in our test point, so I'm going to put in 0, 0 because it's not on that line. So y is 0 less than 3 times 0 minus 1. Well, 0 less than negative 1? No, it's not. So I'm going to shade away from 0, 0. You guys can already start to see where our intersection area is going to be, but we have one more to graph yet. So I'm going to graph that last one, and I'm going to graph it using purple, and I'm going to leave it in the standard form, and I'm going to find the x and the y intercepts for this one. And one more time, put in the test point. I'm going to do 0, 0 again. Is 0 plus 0 less than 12? Yes, it is. So now this kind of starts to get overlapping and kind of scary to see where pieces are overlapping. But what you have to do is just look at each piece. So let's look at each. So I'm going to highlight each one, and I'm going to see, do all three go in that area? Well, if I highlight this piece, not all three go there. Only the purple line goes into that piece, or purple inequality goes into that piece. So that doesn't work. Okay, here's another piece right here. Well, I shouldn't say that whole piece isn't a piece. This piece right here, well, nothing goes in there, so that one doesn't work. Then we have a little piece right there. Well, only the blue goes into that piece, so that one doesn't work. Then we have this piece right here. A little harder to see on those ones, but also have this little part inside there, and you can see in that one again, only the red piece. It's a little harder to see, but the red is the only one that goes there. That doesn't work. We have this piece in this part that the red and the purple work, but that again doesn't get all three. Now the piece that does get all three is this part right there. Now it's a little harder to see that the red goes in there. It's real easy to see that the blue and the purple do, but if I extend the lines of the red, you can see that they are also going to go into that section. So that shaded, highlighted section that I just drew is going to be the solution to this system. There's three. It's harder, but really it's not. You just got to graph each piece and see which ones go together. All right, that's all this for this section. Let me know if you guys have questions. Rewatch the video if you need to. All right.